Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
We know that algorithms are amazing achievements, but they're not good teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to make
We do.
we invite you to join us to make math more figure-outable. Kim, this doesn't bode well for the episode. I don't know.
It's going to be great.
Whew. All right, we can do it. We can do it. I'm alive. I'm awake.
Oh, gosh. Okay, well, at least somebody likes the things that we talk about here. We got a review from CJ Theriot. His last name's... How would you say that?
Theriot? Yeah, one of those two.
Theriot.
Yeah. CJ
says, I'm pretty good at math, and over time, I sort of figured out a few of the strategies that Pam and Kim teach on my own. So he's kind of like me, maybe.
Nice.
But at no point did I have any way to model what I was thinking until I found this podcast.
Woohoo!
Yeah. So had these models and strategies been taught when I was in elementary, middle, and high school, not only would it have made me better, but it would have helped so many of my friends who thought that math was only rote memorizable and not figure-outable. And now that I teach math, I try to incorporate thinking and reasoning over algorithms and rote memory every opportunity I get.
Oh, that's amazing.
Yeah, that really resonates with me and kind of the story of my growing up. Yeah, it's pretty cool. Thanks for listening.
And I'm noticing you pasted it in here that says game changing with 4 exclamation points. Yeah. 5 stars. Thanks. Yeah, that's so well said. And that math is not rote memorizable. Wait, my friends who thought that math was only rote memorizable and not figure-outable. Yeah, that's super well said. Yeah. Yeah.
Okay.
Cool.
So,
nice.
I'm excited about the things we're going to talk about for the next couple of weeks because we get to probably share some stories about us going into classrooms, and we spend some time. Part of the work, besides writing and producing some content, part of the work that we do is going into classrooms, and we film strings with other people's students. Which is super fun. And we're so grateful for the teachers who let us into their rooms.
Yes.
But it also can be tricky because problem stings.
We're doing great.
I know, right? So problem strings, right? You want to make careful choices in planning and preparing for them and what you do with students. And so that work that we're doing going into other people's classrooms, we thought that we would spend some time unpacking a little bit. So if you want to do a problem string, what are the things that you need to think about?
And to start this, kick it off, let's do a quick problem string that then we can refer to throughout the episode. All right. So Kim, I got a few questions for you.
Okay.
I just heard when I was actually in California recently, a bunch of people said to me, we really enjoy the fact that you give Kim these problems and we get to kind of hear what you're thinking about. And so let's do that. Let's do that today. All right. So
let's see if I'm sharp enough today.
Today, neither of us might be.
Right.
No, it's going to be great. It's going to be great. So I have my handy pen next to me.
Got a pencil. I just sharpened a pencil right before we started today.
I believe you. Yeah. Do you have an electric sharpener? Or
for sure.
Do you ever do a hand or it's always electric?
Oh, no. Oh, that'd be kind of fun. I like a good hand cranking pencil sharpener, but these are smooth. Electric pen sharpeners are just so smooth.
Keep going.
I was gonna say, and I don't share it with a classroom of kids anymore, and so they break all the time when there's a bunch of kids messing with it.
Totally. I can handle a good hand one, but it can't be the kind that like it's crooked and and the pencil comes out.
You need a trash can right underneath it.
Yes. If it's the kind that doesn't catch the shavings, no, I can't do it. Can't have that stuff everywhere. It's like graphite.
All right, give me
everywhere.
a problem.
All right, here we go. Kim, what is 10.5 plus 6?
Oh, sweet. It's 16.5.
Okay, so that's not too bad, right?
Yeah.
So even though that's not too bad, I'm going to go ahead and just sketch on my paper. So if I was doing this with students, I would say, hey, great, like 10, I might even say, so you thought about like 10 and 6, and then you added the, I gotta take my glasses off so I can see. And then you might tack on the half at the end, whatever. So I might say, like, if 10 and a half, and I've just written a number line, and on a location at the left-hand side, I've written 10 and a half.
Mm-hmm.
So that's where we are. And then you jumped 6 and we landed. And so now I've done a jump of 6, and then the landing place is 16 and a half. And I've just kind of written that number line. Cool. Next problem. How about if I asked you for 10 and a half plus 5 3/4? So I know this is audio. So let me just say, we have 10 and a half plus 6 is 16 and a half already on the board.
Mm-hmm.
And then I've asked you 10 and a half plus 5 3/4.
Mm-hmm.
Okay. What are you thinking about?
Adding 6 was a little bit too much. So then I'm going to say 5 3/4 is 1/4 smaller than 6. So if adding 6 landed me at 16 and a half, then I'm going to back up a fourth to land on 16 and a fourth.
Cool. And how do you know that 16 and a half minus a fourth is 16 and a fourth?
Because 1/2 is 2/4.
So did you do a lot of like common denominator and like some rule to find a common?
No.
Or do you know something about halves and fourths?
Yeah.
And ideally, would that be like a third grade thing?
Yeah.
Like that if you've got a half, then you have 2/4. And you have 2/4, you have a half. And that relationship would be like kind of the definition of fractions.
Yeah.
Like, what does it
I
mean
actually
to
think
have
it
a
could be
half and fourth?
earlier because,
Okay.
at least in the States, when you mess with money.
So for sure by third grade.
Yeah, for
that
sure.
should be something that kids could just own and not turn into some procedure that they, okay, cool. What if, next problem, 4 1/5, 4 1/5, plus 4.
8 1/5.
Okay, so I'm just going to sketch that out. 4 1/5. Oh, I didn't tell you what I drew on the 10 and a half plus 5 3/4. As you were talking, I added the 10. I started at 10 and a half and I added 6, just like the one I had done above. So I created a new number line, added 6, landed in the same sort of location. I've kind of lined them up, landed at 16 and a half. And then when you said it was too much, I backed up a quarter and then just backed up a tiny bit. And before that 16 and a half, I wrote 16 and a quarter, just so, because we're audio.
Yeah, I
See what I'm
wondered
doing?
actually if you were going to redraw a new number line or if you were going to add on to the one that I.
And you know what? I asked myself that question as you were solving it. And I decided if I was really with students, I would have redrawn the number line, at least for this first problem. Okay, second problem. 4 1/5 plus a fourth. What'd you say? Yep.
8 1/5.
Okay, so I've put 4 1/5 in a place and I have jumped 4 and I've landed at your 8 1/5. Next problem. What is 4 1/5 plus 3 9/10? Okay.
So if I add 4, that's 8 1/5.
Because we did that before.
But that's 1/10 too much because 3 9/10 is 1/10 less than 4. So I want to back up a tenth
From
8 1/5.
Okay, so 8 1/5, back up a tenth. Yeah.
So 1/5 is the same as it's equivalent to 2/10. So if I back up a tenth, then I'm at 8 1/10.
And so I've drawn the same thing I had drawn before. I again drew 2 number lines. So I had your first 4 1/5 plus 4 is 8 1/5, and then I redrew that, and then I backed up from the 8 1/5, backed up a tenth, and I wrote 8 1/10 as the landing spot. Cool. Next problem. How about if I ask you 6 1/3 plus 5? 6 1/3 plus 5.
11 1/3.
Cool. So I've just kind of sketched over here 6 1/3. I did a jump of 5 and I've landed on 11 1/3. Next problem. How about 6 1/3 plus, and I'm just going to pause for a second. So I realize if you're driving in the car, wherever you're listening to us, you haven't been writing all this down. But I might at this point say, hey, if you kind of looked up the board up here or looked at paper or whatever, anybody want to guess my next problem? Because I had 10 1/2 plus 6, 10 1/2 plus 5 3/4, 4 1/5 plus 4, 4 1/5 plus 3 9/10, 6 1/3 plus 5, 6 1/3 plus, and then I'll just let kids guess, and I'm going to say it is 6 1/3 plus 4 5/6. All right, what do you got?
So 4 5/6 is 1/6 less than the 5 I've already added.
Okay.
Or could have added. So I'm going to back up 1/6 from 11 and a third, which is what I got when I added 5.
Mm-hmm.
And back 1/6 is 11 and 1/6.
11 and 1/6. Then how do you know that?
Because when I had 1/3, that was 2/6. And so if I back up a 6, then I'm at 11 and 1/6.
11 and 1/6.
Mm-hmm.
And how do you know that 2/6 is 1/3?
It's a great question. How do I know that? I mean, I guess I've just messed with. I think about like the ratio of 2 to 6 is the same as 1 to 3.
Okay. Okay. And if we had something and we were sharing equally, 3 of us were sharing equally, you'd get a third, I'd get a third, the other person would get a third. But if I said, but we're actually going to share with 6 people, 6 of us are going to share equally, how would those 6ths relate to those thirds? And we would want to make that connection, right? Early with kids. That's like the definition of unit fractions. What does it mean to be 1/6? How does that relate to 1/3? If you actually have kids take a strip of something and say, hey, fold that into 6ths, often they'll do it 2 ways. And one of the ways is the way you just did it. They'll fold it into thirds, and then they'll cut those thirds in half to get 6ths. Can you think of another way? Kids might do that.
Can I admit that I'm not listening?
Sure.
Sorry.
Another way that kids might find 1/6 is they might fold the thing into half and then cut the half into 3 chunks to get 6.
There's a red cardinal out my window. I'm so sorry.
Hey, do they sound pretty? Because we were out on a walk and I was like, what is that sound? Like, so my son pointed out, he's like, I think it's that cardinal right there.
Maybe. We have a ridiculous amount of birds, and so we hear them all the time, but I have not distinguished one from another kind.
Do you do bird feeders? Is that why you have birds?
We have one in the front of our house. It probably doesn't have any stuff in it because that takes regular maintenance.
Are you not a regular maintenance kind of gal?
Jeez.
Let me guess. You didn't hang it up. So
I did not.
Whoever hung it up, you were like, "Okay, it's on you, sucker."
Yeah. My youngest just recently said, "Hey, we should probably put some stuff on that."
Nice. All right. So Kim, we've done a string where I gave you a problem where we kind of added a nice number, and then I gave you a problem where we added something that wasn't as nice, that was a little bit smaller than that.
Yep.
And you chose every time to kind of say, well, if I know what that adding that nice number is, then I can just back up a little bit to kind of adjust. And so a little over with fractions. Okay, cool. So we did that problem string. If we were going to do that problem string, or if we're in a place where we're trying to choose problem string to do with kids, what are some things that you would ask yourself as you're thinking about, what like, how would you choose this string? Or like, what in general kind of, what do you ask yourself about choosing a problem string?
So one of the first things that I think we could think about is, am I going to choose a pre-written string, or am I going to try to write my own? And I don't think that that's a trivial question. I think there's a lot of people who are attempting, they're seeing great strategies out there and they're like messing with numbers and they're thinking, what do I want to do with my students? And so they're attempting to write strings. And, I think up front, we should just say it was a lot of time had passed before you and I were writing problem strings.
And not just time, right? It's not just like,
and experience.
Experience. We were facilitating pre-written problem strings that someone else wrote, who'd thought carefully about the relationships, knew the structures of strings. And we would be like, I wonder how this one's going to play out. And then we would give it a go. And also one of the cool things I think that was super helpful for me was I would do a problem string a few times in a workshop or with students. And then you and I would do one together, like a workshop together, and you would facilitate it. And I'd be like, why'd you do that? Like you would do a move I hadn't thought about, or you wouldn't do a move I did. And then the two of us we would like scurry together, hey, tell me more. Oh my gosh, I totally just dropped stuff on the floor. Our editor's like, what are you doing, Pam? Sounds go everywhere. That was really impactful for me to realize that I was making certain choices to facilitate the string in a certain way. And you were making other choices, and man, we learned from each other. Like there were times where I would adopt what you were doing, and there were times I think that you would adopt what I was doing. And there were times where we'd both stop something and choose, to wonder about something else. So that was, yeah.
And some of those moves were specifically about facilitation, but some of those moves that we made were based on the numbers in the string. And so at that point, we really looked hard at the types of numbers and it really honed skills on writing strings. But the good news is you can still facilitate problem strings even before you feel ready to write your own. It's great. It's a great practice to start writing your own and compare with other people. But you can still facilitate well written strings even before you feel ready to write your own. We have tons of problem strings on the Math is Figured Out website, and great news, we have grade level problem string books that you can purchase to get a year's full of strings. So first decision.
Well, let me pause. So that's
Yeah.
kindergarten through 5th grade. And if you're a middle school, then I've got lessons and activities for building powerful numeracy. And if you're high school, algebra
Yeah.
problem strings, advanced algebra problem strings, great. Prewritten strings. And Kim, I run into a lot of people who say, okay, I know I'm supposed to be writing strings. And I'm like, whoa,
Yeah.
like
Yeah.
you can just facilitate pre-written strings.
Mm-hmm.
I don't think teachers have to be content creators and expert teachers at the same times. I
Right.
think they can find good content and just get really good at facilitating it.
Mm-hmm.
Yeah.
Mm-hmm. Yeah, because there's so much to consider even in a bank of problems. So it's really about knowing your content and knowing your kids. So things to think about. Where are you in your year?
Mm-hmm.
Is it the beginning of the year, middle of the year, end of the year? What precursor knowledge do students already have or do they need to have in order to do a string that you're thinking about choosing?
Yeah.
So like the string that we just did.
Yeah. Can I tell you what I was thinking
Yeah.
about? So one of the things that I considered was what would be numbers that I was pretty sure podcast listeners could kind of hang on to. Some of you are like, I had a hard time hanging on to those fractions. And I'm aware of that. Like I'm aware that when I say 10 and a half plus 6, that probably most people were able to kind of hang on to that,
Mm-hmm.
adults listening to the podcast. And so that on purpose was like the first problem because I was pretty sure you'd be able to hang on to that. And then I don't know if you noticed, but I tried to say often. So if 10 and a half plus 6 is 16 and a half, if like say that over again, so that then maybe you have a prayer of hanging on to 10 and a half plus 5 3/4,
Mm-hmm.
because 10 and a half and 5 3/4, many people will be like, whoa, like I got to write that down to hang on to those. Totally. That makes sense. But I was pretty sure that the fractions I chose, especially adding a whole number, at least people could hang on to that first bit, the helper problem of the string. But I was also aware there's probably going to be some people listening to the podcast who are like, wait a minute, you put a fraction on a number line?
Mm-hmm.
And that might be a new idea. I often work with teachers where I'll start putting fractions as a location on a number line and they go, whoa, I've never thought about that. I've always thought about, like we did one of the problems was 3/4. I've always thought about that as 3/4. And I've counted 3 and I've counted 4 and I've shaded the 3 out of the 4. So they've only ever thought of 3/4 as 3 and 4 and not really as a location on a number line that I could go over 5 and then 3/4 more of a unit and mark that as a location.
Mm-hmm.
So I was aware of that tension, but I thought the way we did it, and that's one of the, I thought the way we did it would help people kind of come along. And one of the reasons that I kept talking about what I was drawing was to help people realize you can put a fraction as a location on a number line.
Yeah. Yeah, because the idea is that they can enter into the problem string. That right
Mm-hmm.
off the bat, it's not like, a smack in the face. I'm not even sure how to get started. So where you are in the year and what precursor knowledge is super important to think about. The
Yeah.
other thing that is important to think about, I think we all will address, is what content do you need to address right now or that you're trying to get at?
Mm-hmm.
While it's fine to be working on, an addition string while you're also working on division, there are some times where staying in a particular lane is super helpful for kids. And we'll talk later in another episode about how you choose what to do at what time. But if you're working on division and that's the meat of your class, you might want to stick with a multiplication or division string so that kids are tinkering with strategies that you're going to want them to use in the rest of their math time.
And they're building multiplicative reasoning, which
Uh-huh.
is necessary for them to reason through division.
Yeah.
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 Yeah. Nice.
Another really important consideration is what size numbers are your students ready for?
Mm, yeah. Yeah. That's a big one.
Yeah. So if it's beginning of the year, third grade, clearly I'm not going to start with 3-digit multiplication times 2-digit multiplication. We might get there, but we want to think about what can my kids handle and what's the ramp up of the string look like. Even strings that start with smaller numbers in the beginning could ramp up pretty quickly inside of a string. So just looking at the numbers, kind of analyzing what's happening throughout the string, are the kids going to be able to handle what's going on? We want a little bit of a push, but not so much that right off the bat they're struggling with the numbers and they
Floundering.
can't
Yeah.
they can't mess with the strategy that's happening. Because when
Yeah.
the numbers are too big, often we see kids revert back to less sophisticated strategies.
Mm-hmm.
And
Mm-hmm.
so we want to keep it within their zone of proximal development.
Would you say that when we're starting a strategy, we actually kind of keep the numbers really manageable so the kids they're not fussing with the numbers so much.
Mm-hmm.
They're noticing the pattern of the strategy. But after
Mm-hmm.
they kind of have an inkling of the strategy and they've started using the relationships, then we make the numbers harder. So they're also building kind of place value in the
Yeah,
sense of numbers because they kind of have a sense of the strategy.
for sure.
Yeah, nice.
Yeah.
What else?
Also, something to consider is what strategies do students already own?
Mm,
So, we have talked a lot about the different strategies for each operation.
hmm
And, in your big ebook, we've outlined what those strategies are. And there's kind of a sophistication order to them. A lot of people see that most sophisticated strategy and they say, oh, sweet, that's the one I'm going to teach my
Let's
kids.
go there. Let's
Uh-huh.
skip all that
Uh-huh.
unsophisticated stuff. Yeah.
Yep. But in learning and developing the precursor strategies, the other strategies, kids are building their brains, let's say multiplicatively. If it's multiplication strategies, they're building their brain multiplicatively as they learn more strategies
hmm
so that they can be equipped to handle the most sophisticated ones. So, what strategies do kids already own comes into play. You're not going to start a year teaching the most sophisticated strategy.
hmm Uh, depending on the age of the kids. So
Yeah.
I might take high
Oh,
school
that's true.
kids.
Yeah. Older kids, you
Yeah, I
might.
might take high school kids and just do give and take for addition
Yeah.
and not mess with the precursor ones because ideally at that now it depends on the kids, but if I have sort of a what's a mainstream kind of gen ed population, I think I probably could start with some down the numbers again, but like getting them kind of thinking about if we've
Yeah.
got pile of marbles and yeah. So depending on the age of the kids, you can
Yeah,
s-
I
skip
agree
some of the
because
precursor.
their work is not, while you need to build additive reasoning with them,
hmm
that's not the work of their grade level
Right,
necessarily.
right. So we're
So,
gonna do a
yeah.
little bit of that
Yeah.
work. Yep, yep.
And
Nice.
people will notice that we did that in the K-5 problem string books.
Oh yeah, that's
Yeah,
true.
I don't know if we've ever
Yeah.
said that out loud, but as the books get older grade-wise, we made some choices about leaving off some of the lesser sophisticated strategies,
hmm
so that we can deepen, broaden the size of the numbers and the
And
types
as the
of
grades
numbers.
go down, we even built precursor strategies
Mhm.
with smaller numbers, like
Mhm.
single digit numbers, before then it kind of grew up into kind of the major
Yeah.
strategy with larger numbers. Yeah,
Yep.
nice. Yep.
So another thing to consider is, am I trying to build a model or am I trying to build a strategy?
Mm-hmm.
Because there are strings that do both. And if it's a time where my kids have not messed with a model before, they haven't experienced that, we haven't developed it, then I'm gonna maybe make some choices about the numbers so that they can
Down
make
the
sense of the
numbers.
model. Mhm.
Yeah, down the numbers so we can just make sense of the
Mhm.
model.
And when we say down the numbers, that means we're just going to be looking for pre-written strings that have smaller numbers. That doesn't don't hear that as us saying, okay, now write one that has smaller numbers. We're still living in the land of there's lots of pre-written stuff to choose from, but those are the
hmm
kinds of things you're thinking about.
Yeah. And down also can mean less complex.
Mhm.
It doesn't necessarily have to mean smaller. So I
Mhm.
might deal with like the over strategy that we just did. I might deal with add 200, add 199.
Mhm.
That could be less complex than add 80, add 77 because it's just one down versus three down.
Yep.
I don't know if that's the best example, but or add 600 and to help with add 599 is going to be easier than add 200 to add 188.
Mhm.
188 to 200 is a bigger gap. Yeah. Okay. So less
further
complex
away.
numbers.
Yep.
Okay.
Also thinking about what models have they experienced? So
Mm-hmm.
are you building the model? Are you extending the model?
Mm-hmm.
Are you trying to take a strategy they know and they've experienced on one type of model, but now you want to experience that strategy on a different model?
So a really good example of that would be the string that we did today. I don't think I would do an over strategy with fractions without having done an over strategy with whole numbers first,
Right.
which could mean not an entire. So if I'm doing fractions like these, I'm probably in at least 5th grade up, maybe 4th grade. I could do this in 4th grade, but not for sure until I had done work building whole number, the over strategy with whole numbers. But if I was in like middle school or high school and I wanted to do these fractions, I could have done these exact 6 problems that we did, but I probably would have done a helper clunker pair to start this string with whole numbers, or maybe even 2 with, like more complex whole numbers, and then go into fractions. Yeah. What else?
Another thing, I kind of mentioned this earlier, but is this in my content right now, in my curriculum, that I'm supposed to be working on in my core group? Is this in my content string, or is this a review string? Like, am I going to cycle back to a strategy maybe my kids have already experienced, but I don't really see them using anymore? And so, but I want them to. It's sophisticated and maybe they just aren't really using it. I want to circle back to it. Or is it something we're just seeing for the first time?
So you want to consider both of those. Those should both be happening in your classes.
Yep.
What else?
When I go see students for the first time, one of the first questions I ask their teacher is, have they ever done problem strings? I know that about my own students, but is the string going to be routine? Or am I introducing procedures that might affect the length of the string that I'm going to do? So you can
intro,
get away with some
right?
longer,
longer strings. My intro differently. If kids are starting to copy down everything, you might have to have a conversation about this isn't about copy mode. Yeah, that's super important. You and I were just preparing to do some videoing, and both of us were asking that question, like, have kids ever, and it was drastically different in the room that one of us was going in the other one. And so one of us could just like dive in and do a new strategy with new numbers. And the other one was like, let's talk about what your role is in this. Because one of the things that we often get people missing, that they'll misunderstand, is that we're advocating some loosey-goosey, go have kids wander around discovering math on their own. No, not at all. And they think that we're advocating like an unstructured, unclear, kids don't know what their job is. And very to the contrary, when we're doing a problem string, we're going to help kids be extremely secure in what their role is during a problem string. So much so that's when kids go, it's almost like you want us to use what we know to solve the problem. Yes, that is your role right now. So use what you know. Let's explain each other's thinking. Yeah. What else, Kim?
I think the last one that I was thinking was time. How long do you have to do a problem string? Again, that'll affect the number of problems that you want to do. If you have you need a quick problem string, you might do just a few problems. If you have a little bit more time to explore, then you might do a longer string. Again, that also has something to do with if it's routine yet, or if they've used a particular strategy before.
Yeah, nice. So all really good things to think about when you're choosing a problem string.
Yeah.
Thanks for letting us in your head.
So we have other problem string focused podcasts.
Yeah, so if you're interested to listen to us talk more about problem strings, check out episode 33, 71, 72, 163, 226, and 241. Good gravy, Kim. Have we really done that many podcasts?
Yes.
That's awesome.
I mean, we do them all the time, but those are specific to learning more about problem strings. Listeners, we thank you for listening and for leaving us a review and for sharing the Math is Figured Out movement alongside of us. We love doing this and we want as many people to know. So we are grateful for your sharing.
Yeah, thank you for tuning in, teaching more and more real math. To find out more about the Math is Figured Outable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figure outable.